In this problem, we have triangle ABC that is inscribed in triangle PQR. We have the vertices of PQR but not of ABC. Instead, we have some clues as to their locations. A is a midpoint, B is found 3/5 of the way along PQ, and C is found at a ratio of 3 to 5 on RQ. We need the perimeter of triangle ABC. First thing we're going to do is find midpoint A. To do that, we are going to use the midpoint formula, which looks like this. Plugging the vertices of P and R into the midpoint formula and simplifying, I get the answer 1, 5. Midpoint A has an x-coordinate of 1 and a y-coordinate of 5. I'll label that in my original drawing. And now it's time to move on to the next step, which is to find point B. To find point B, I need to use the ratio formula, which looks like this. Since B is 3/5 of the way along PQ, that means it is found at a 3 to 2 ratio between P and Q. My A is 3 and my B is 2. Using those values and the coordinates of points P and Q, I fill in my ratio formula like this. Simplifying, I find that point B has an x-coordinate of 36/5 and a y-coordinate of 19/5. And I label my drawing. Now it's time to move on to point C. Point C is found at a ratio of 3 to 5 on RQ. Therefore, if R is the starting point and Q is the ending point, A is 3 and B is 5 in my ratio. Using the ratio formula again, with A equals 3 and B equals 5, and plugging in the coordinates of vertices R and Q, the simplification will look like this. I end up finding that the x and y coordinates of point C are 25/8 and 13/8, and I label my drawing accordingly. Now that I have found the coordinates of A, B, and C, if I want to know the perimeter of triangle ABC, I have to use the distance formula 3 times to find the lengths of AB, BC, and CA. Let's start with AB. Filling in the distance formula with the coordinates of A and B, I simplify, and I find that the distance between A and B is 6.315 units if rounded to the nearest thousandth. I will record that AB is equal to 6.315 units. Now let's move on to finding the distance BC. Plugging in the distance formula with the x and y coordinates of B and C, I simplify, and I find that BC is 4.619 units in length, again if rounded to the nearest thousandth. I record this, and now let's move on to finding the distance AC. Plugging in the vertices A and C into the distance formula, I simplify and I find that AC is 3.988 units long, again if rounded to the nearest thousandth. And I record that. It's time to find the perimeter of triangle ABC, which I will find simply by adding together the 3 distances I found with my distance formulas. When I do that, I get 14.922, again if rounded to the nearest thousandth. But because there is a scale of 1 unit is equal to 10 meters in this drawing, I have to multiply by the scale. And my result is the perimeter of triangle ABC is 149.2 meters if rounded to the nearest tenth. Take note that even though I'm writing all of these values down on my paper, rounded to the nearest thousandth, Those are not the values that I'm using to make my calculations. I'm using the memory of my calculator to use the entire value without rounding off so that I don't round off until the final step. This will make my answer as accurate as possible. This is how we use various formulas from advanced straight lines to solve a multiple step problem.